Hi guys, my name is James Jersick. I'm the Laboratory Director and Quality Director for NootropicsDepot and Omnient Labs. And I want to take a few minutes to describe in this video a phenomenon that we're familiar with that we think many people don't know about, which is the concepts of dry labbing and lab shopping. Before I get into that, I want to talk a little bit about myself. I have a BS in chemistry and biochemistry. I have a master's degree in biochemistry and de novo protein design. I've worked as an analytical chemist, an analytical chemistry technician, a method development chemist, an organic chemistry instructor at both Arizona State University as well as the community college systems here in Tempe and Phoenix. And I've been doing chemistry for quite some time now. I'm currently a member of AOAC, which is an analytical chemistry industry group. Part of the CASP working group is a Cannabis Analytical Science working group. I go to ICSB, which is the International Conference on the Science of Botanicals. I spent a lot of time doing science on botanicals, both around here and in my career. I do consulting services for companies like Waters and KMag and PerkinElmer and some of the other big equipment manufacturers. So I'm very plugged into what the manufacturers are doing and the state of the science, especially in dietary supplements and plant science in general. In this video series, we want to cover lots of different topics, but specifically for this video, we're going to focus on dry labbing and lab shopping and some C of A red flags. Because when I see a C of A, a certificate of analysis, from a manufacturer, a vendor, a seller, an online marketplace, wherever it may be, there's often things that I see in the video or see in the file or see in the document that are, for me, red flags. Things that just make me say, I don't think this is real. I think this is fake. I think this is dry labbed. I think this is lab shopped. Something is going on with this. And I want to give you the tools in this video to be able to identify those same things. So that said, we'll jump right into it. So first of all, what is dry labbing? Dry labbing is the process of fabricating laboratory results. There's lots of different ways that labs can do this. Sometimes they can just completely not even exist as a laboratory and they just issue documents as if they were. Sometimes what they do is they have an analysis that works for one thing and they might do that test or that analysis on a different material and it doesn't work, so they just fudge the numbers to make it work, right? This is a highly unethical, probably illegal in many places, laboratory practice, but labs are businesses too, and they have the same business pressures that a lot of places have to get out passing results. Otherwise, lab shopping occurs. Lab shopping is a process whereby customers intentionally submit the same sample to multiple different labs to see which lab gives them the desired or the right answer that they want. What they then tend to do is labs that don't give the results that they want, even if the material is legitimately a failing material, is they just don't use that lab anymore, right? So they intentionally go around and pick different labs and shop for which ones will give them the right results. Over time, what happens is laboratories tend to lean towards giving passing results so they get repeat business rather than accurate scientific results, which may result in losing business. It's an actually inherent flaw in the business model of a laboratory because the science and the economics and the business side of it don't always agree with each other, especially when materials fail or fail maybe just slightly. Then you get into the, did it really fail type questions, or is your method appropriate type questions, and other detailed science conversations like that. The more shadier companies, the vendors, manufacturers, the sellers, and sometimes the labs as well, are borderline in cahoots with each other to make sure that the company will submit samples to the laboratory, making the money for the laboratory, but at the same time, the laboratory will be sure to issue passing results to the company. It's a hugely ethical problem, and it does exist. I don't know the extent to which it exists in the industry, but we have experienced ourselves through some experiments that we did when we intentionally went to lab shop to see who was dry labbing, who was not, and we found some things that we're going to tell you in future videos. Okay, so that said, I would just like to pull up a few C of A's that I've cherry-picked from the internet, and I'm not trying to say or assert by any means that these certificates of analysis are dry labbed or lab shop or anything like that, but they are documents that I found freely available, publicly available online, that I've tried to redact to the best of my ability to say when I see documents that look like this or have properties like this, it causes me to make this face. And I would like to give you, the customer or the consumer of these products, the ability to critically read a C of A so that when you see similar types of questionable activities on a document or questionable content on a document, you can kind of say, I don't know if I trust this, right? Merely being ISO accredited, merely being a third-party lab doesn't automatically guarantee proper scientifically valid results. And here are some hints as to what you can look for to see if that's actually the case. For the first C of A, this is a one-page document. I have redacted the document to the best of my ability. My goal here is not to call out any particular company or any particular lab or even any particular product, but rather just highlight the issues that I see with the C of A. So again, this is a one-page document. The large black squares are redacted per me, which includes the laboratory number. I'm not really sure what that is. Not a common parlance. It's not an acronym or any type of communication that's typically used, but in the event that it could be used to identify this product, this lab, this company, anything like that, I wanted to pull it off anyway. So a couple of the main problems I see with this C of A is, first of all, the product lot number is not really a lot number. It just says L-theanine 1, which makes me think, okay, they didn't really submit an actual quality control material, a QC material, or a QC lot. They just submitted some generic material. And that the second issue that I see with this C of A is that the assay value is merely listed as 98.8%, and the method is listed by HPLC. So first of all, HPLC is not a method. It's a methodology. It's an instrument, right? So if someone were to give you a batch of cookies and you taste them and you're like, oh, these are really good cookies. How did you make it? What's the recipe? And they said oven. You would look at them like, what does that mean? Oven? Oven is a tool that you use to make cookies in the same way that HPLC is a tool that you use to measure the assay value or the quantity value of a given material. Because of the way the tool works, it is not capable of identification. That's just not how HPLC works. And so if you look closely at this document, the description for identification is listed within method of HPLC. And as I said before, HPLC is a tool by which you can determine the quantity of a thing, but it can't determine if the identity of a thing is true. So when I see a method listed as HPLC for identity, that is not a scientifically valid way to determine the identity of a material. In addition, the results for that very test are merely listed as positive. What does positive mean? What does it mean to be a positive result? Does it just mean you have to have some there? So something that has an assay value of 1.0% would be identified as a material, in this case L-theanine, as the same way as something that is 98 or 99 or 100% L-theanine? What does it mean to be positive, and how do you become positive on an HPLC for identification? So that line of text right there is just a huge red flag. When I see that, I think that these guys don't know what they're doing. They're not using proper science for identification. For those of you unfamiliar or outside the US, a red flag is this symbol right here, this little action. If you follow American football, when you throw a flag on the play, it means that something went wrong, right? A penalty has occurred. I guess for you international folks, it would be, a red card or a yellow card from soccer or rugby or something like that. So this is just one C of A that I found that just inappropriately uses HPLC as an identification method or methodology, and to me it just strikes me as something is going on here. I personally would not trust this document, and I likely would not trust the company that issued such a document. So now I'll move on to another C of A that I've picked out, in this case for a material called phenibut FAA and 10004-104A, something like that. This document is one that I found on the internet, just like all the others. I've redacted, just like before, the company logo, lab address, company name, names and titles of people that are relevant to this discussion. And I just want to highlight a couple things that, when I see a document like this, make me make the face. So let's zoom in on this report of analysis section so that you can see it. And we have a couple things to note. First of all, they say the powder in the jar was analyzed for identification using Fourier transform infrared spectroscopy, FTIR. That's good. FTIR is a valid way to identify powders and crystalline materials. The resulting spectrum matched a reference standard of this material. Okay, well, they are using some sort of material as a reference standard, so that's good. They aren't merely saying we use this instrument and therefore it magically passed the test. They're using a reference material, so that's good. But the problem that I see with this is that they say the resulting spectrum matched. Just like before with positive, what does it mean to match? If you take the spectrum of the reference standard and the spectrum of your sample and you overlay them, and they match perfectly, that could be a match. But what if they match not so perfectly? What if they're a little different? Is that a match? Is this a match? What is exactly the threshold for when something qualifies as a match and when it doesn't? This document doesn't say. It just says it matched, and we're just supposed to believe it, I guess. Okay, well, let's believe it for now. Let's move on to the next part. The material was analyzed for purity using high-pressure liquid chromatography. Okay, that's a reasonable way to make measurements of a material. The detector was set to 193. The results are summarized in the table below. So here's something that you guys don't know because you're not analytical chemists and you don't know this, but I am and I do. When you set a detector at 193, you're not looking at what's called the lambda max of the material. You're not looking at the particular wavelength that the material best absorbs at. You're essentially looking for any organic compounds that happen to show up. So that can sometimes be good and useful, and in fact, reference material labs will often use wavelengths like that for what they do. But for QC analysis and third-party testing labs and things like that, you should be choosing a different wavelength. So when I see 193 or 195 or even 190 sometimes, I say, this method really probably isn't fit for purpose, probably isn't validated. There's other issues with this data set. Then when I go on and I look at phenibut FAA sample and it says chromatographic purity, now is when the big red flags start going off in my head. Chromatographic purity is not absolute purity. When you buy a material and it says purity 99.9%, what you think is if I take 100 grams of the material, I will get 99.9 grams of the thing of interest. That's typically what people mean when they say the word purity. But here, specifically, the laboratory has chosen to say chromatographic purity. So, and then in parentheses, percent area. So what does that mean and how is that meaningful and why does that throw a red flag in my head? So let's look at that next. So this is the HPLC that is provided with this C of A, again, freely available on the internet. I would like to just make a quick note that the material is now being called phenibut FFA 2004-10A instead of phenibut FAA 2004-10A. Probably just a typo, but it happened there, it happened there. It happened again in the quantification method. It's scattered throughout the document with this small typo. But this highlights how much control individual humans have over this process, over the entire measurement process and the generation of the certificate of analysis, as well as of the chromatogram in this case. So this is the entire chromatogram. It's one page. You can see in the upper right-hand corner, it says page 1 of 1. And they provide this chromatogram, which is this box or this graph in the middle, along with some results in the bottom in the table. So let's take a little bit closer look at this table. Down here, you see 3 line items in this table with ret time min, that means retention time, and they correspond to the little tick marks that show up on the graph above. So 2.12 has the number 1, 2.91 has the number 2, and then 3.36 is peak number 3, which is listed as phenibut FFA, supposed to be FAA, with a big peak, right? So what the software does is it uses little tick marks and it measures the area under the curve, using your calculus that everyone hates, and it determines how much of all the stuff that got integrated is attributed to each peak. So in the first peak at 2.12 minutes, the total amount of area in the chromatogram because of that peak is 0.06%. That's this column over here on the right, the 1, 2, 3, 4, 5, the 6th column under relative area percent. For peak number 2 at 2.91 minutes, the contribution is 0.01%. And then the kicker, which is where the company selling this material wants to get their claim from, 3.36 minutes, a relative area percent of 99.93, right? That's where, coming back to the original C of A, that's where this number 99.9 comes from. And that's why it's listed as chromatographic purity. So what does that mean? What that means is the software has been set by a human in some fashion, using some standards, to intentionally integrate certain peaks. You can change that all day and all night. I could make this material 100.00%. I can make it much more than that. So for example, if you were to look at about 8 minutes on the x-axis right here, all the way to about 15 minutes, there's that big kind of blobby, clumpy looking thing. What is that? Why is the software not integrating it? Why does it not count for area percent? It's most likely because the human operating the instrument and the method and the software has chosen to tell the software, don't integrate that stuff. And therefore it doesn't count with respect to area percent. Because if it did, it would lower the 99.9 into a significantly less area. Now maybe that's correct scientifically, and maybe it's not. We can't know unless we know the details of the method. Maybe it's an artifact of the method, maybe it's an artifact of the column, maybe it's just junk in the system. You know, systems aren't perfectly clean all the time. There's lots of reasons why that might be there, and we see that all the time in our lab, and we know what it is, and we can explain it, and that's fine. And is that what's happening here, or is it not? I don't know. But here's another reason why I don't trust chromatographic purity to mean absolute purity. And it has to do with the way that the HPLC works. HPLCs are blind to salts. They cannot see ions, magnesium, sodium, chloride, all those guys. They cannot see them. They only see some organic molecules under some conditions. So if you take a material which is 100.00% pure and you dilute it 50-50 with sodium chloride, let's say, and you inject it into the HPLC under these chromatographic conditions, what would the chromatogram look like? What relative percent area would you get? You'd get the exact same one. You'd get 100% relative area, because all of the ions, which make up 50% of the mass in our thought experiment, won't be seen by the instrument. So of the things that the instrument sees, it would be 100% of what it sees, even though it's only 50% of the material itself. And that, my friends, is the difference between chromatographic purity and absolute purity. So when I see a company that's selling a material that's claiming to be 99.9% absolute purity, but then their supplementary data is supported with chromatographic purity claims, that makes me say, ooh, man, I wouldn't trust that material, I wouldn't trust that lab, I wouldn't trust that company. Just way too many red flags for me to ingest something that has those types of claims. Now the lab might have told the customer that ordered this test and provided the material that they were doing this. They might have said, this is how we do our test. And the customer might have said, yes, that's fine. We're gonna just surreptitiously substitute chromatographic purity for absolute purity. Or maybe they didn't. There's not really a way to know here unless you know the relationships between the lab and the samples and where they come from and things like that. But when I see a document like this and I see a claim with chromatographic purity, to me it's a red flag for we're not making a proper absolute measurement, but rather we're making a relative measurement. And since we don't know all the parameters of that relative measurement, it's not really meaningful. And then last, the company does also provide their FTIR. So I look at an FTIR like this. The name is now corrected to Phenibut FAA. I've again redacted the company name and logos and analyst names because those are relevant for this discussion. And when I look at something like this, instead of, I could read it if I needed to, but I look at it and say, yeah, it looks like they actually did the work. We got the right sample with the right lot number on it. This looks like what an FTIR would look like from a Phenibut sample. So everything pretty much looks okay there to me. I mostly look at this and say, okay, good. If I needed to read it critically and evaluate what is this peak, what is this peak, what is that peak, I could do that, but generally I don't unless there's other reasons that make me spend the time to do that. Okay, so let's move on to our final C of A number 3. For this one, there's lots of content and lots of information on this document. Again, just as before, I've redacted customer, contact, phone numbers, report numbers, yada, yada. You know, I don't want people to go dig these things, these companies and these products up. I just want to highlight a few key points. So first of all, the sample name is called terkesterone. So it might be a little difficult to see. So we'll zoom in on it in a second. And the main two things I want to point out here is two things. One, we have analysis in the middle for heavy metals with a specification and some results. And at the very bottom down here under test code TUC05, which I'll zoom in a second, it says terkesterones total. So let's take a look at that. So in this test, they call it TUC05. That's their test code for how they describe the test to make sure that they do the right test on the right material. It makes sense. They're calling it total terkesterones, which is a thing, UV-Vis, with a result of 160.21 mg per serving, a specification of no less than 120 mg per serving, and a test note of 1 serving equals 2 capsules. Well, that's pretty common. 1 serving equals 2 capsules. We see that all the time. TUC05 is just an internal test code. I'm not too worried about that. That doesn't bother me. I don't care. Here's where the flag happens in my mind. When you see terkesterones, plural, with an S, it implies that there are multiple molecules called terkesterone, and that's not true. Terkesterone is one molecule. It's one thing. But they're saying total as if they're adding up a bunch of things to get to a total, and that's not true. Terkesterone is a molecule. It is a subtype of a class of compounds called ecdysteroids, of which there are many different permutations that plants make. And so when you measure total terkesterones using the methodology that they do, that I'll get into in a second, it inherently immediately throws a flag in my brain that says something is awry here. This is not right. So looking more closely, you can see in parentheses it says UV-Vis. What is UV-Vis? UV-Vis stands for ultraviolet visible spectrophotometer. It's a way to make measurements, and for some materials, under some methods, a UV-Vis measurement is just fine. We have one in my lab, we make them all the time. It depends on the material and the method and what you're trying to do. However, when you have a complex matrix like a plant material or a plant extract where there's lots of different molecules and lots of different molecules that are very similar to each other, the UV-Vis does not distinguish them from each other. The way that the UV-Vis works is basically you take your sample, you extract it up, usually your sample is a solid state, you mix it in liquid, you put it into your cuvette, you take the cuvette, you put it in the instrument gives you some sort of measurement or absorbance. Ideally, you should be comparing that to a calibration curve with analytical standards and things like that, and you get a final answer. In this case, they're claiming that their final answer is 160.21 mg per serving of total terkesterones. I don't think that's true. I think what they're actually measuring here is the sum of all the ecdysteroids, of which there are many types, terkesterone is one, plus other stuff that shows up in the sample, which is the sum of reflectance, refractance, and other random absorbance due to the other molecules. This is an inherent flaw in the methodology or methods of UV-Vis technology when you're making measurements, is that because, unlike in chromatographic systems where you're specifically separating peaks into distinct things that you can then quantitate separately, in the UV-Vis you're not doing that. It's a one pop mix. Take all your stuff, put it in one spot, make one measurement one time, get one number, bingo bambo, you get all your stuff. That just doesn't work when you have a complex mixture like this. And so I know this because my lab spent a lot of time measuring beta-ecdysterone as well as terkesterone, which are ecdysteroids, the class of compounds. And what we found was that of all the products that are on the market that we were able to purchase and test, as well as all of the products that we were able to obtain from the raw materials providers, none of them had an appreciable amount of terkesterone in there, even though they were labeled to have terkesterone in there. And if you go look at our Reddit history and other Reddit posts that I'm not going to get too much detail right now, you can see there's a long history of the terkesterone discussion at NootropicsDepot and at Omnient Labs. And so most of the time what we found was that materials and products that were labeled as terkesterone were actually high in content of beta ecdysterone, which again is a different type of molecule, but the measurements were often conflated, right? Some labels would say total ecdysterones or ecdysteroids. Some would say terkesterone. It was a huge mess. So what we found that the total amount of actual terkesterone in products on the market as well as in raw materials was trace level, 1 ppm, 10 ppm. I think a couple products we saw were a couple mgs per capsule against their label claim specification of 250 mgs per capsule, things like that. So nothing past label claim for any of their terkesterones. So when I see a product that, or a test result that is both improperly named, terkesterones, plural, should see. If it said total ecdysteroids, I'm like, okay, well at least now we're trying to get in the realm of the right class of molecules being measured. And then I see the UV-Vis measurement and like, okay, this is probably not an ideal method. This method is not fit for purpose for this material, and it's unlikely that this result can be trusted. So yes, at the end of the day, they have 160.21 mg per serving on their certificate of analysis against their specification of 120, but I personally don't believe it, and it's a little suspicious. So moving on to the next thing. There's a difference between the certificate of analysis that's provided by the laboratory and the C of A or certificate of analysis that's provided by the company that sells the material. right? So what we're looking at now is page 2 of the certificate of analysis that's offered by the company itself. It's different from the first document that we looked at, or the first image of this document that we looked at, insofar as, if you notice, for heavy metals in this case, it has specification 10 micrograms per day, 4.1 micrograms per day, yada yada. Method, just like before with the HPLC thing, it says ICP-MS. ICP-MS is not a method, it's an instrument, right? This is the oven and cookie argument all over again, right? It's not a method, it's a methodology, or it's an instrument. It's a way to make measurements. The result here is merely complies. So I'm guessing that we're going to have to think that the number that you get for, in this case, arsenic, is anywhere between 0, which is very difficult to measure, and we'll talk about that in another video, and 9.999999999 micrograms per daily dose, right? Could be any of those numbers. Is there an actual number? Yeah, there is. Do they put it on the document? No, they don't. Why don't they do that? When they actually provide the results from the laboratory in a separate document. And you can see here, arsenic 0.656, cadmium 0.08. I mean, these numbers are fine. I don't know why you would hide them. But when I see a discrepancy between the certificate of analysis and the results that are posted by the laboratory, and the results that are posted merely as words, complies, by the company, to me it makes me think they don't really know what this means, or they don't know what their liabilities are, or there's some confusion as to what's going on here. And it just makes me make this face, like, I don't know what I think about that, right? You have results, you have specifications, you probably have a valid methodology or method, even though it's not properly stated. Just post the numbers. Like, don't just fake it with words. This is the same problem with the FTIR matches, right? Say what it is that it's matching to and how you're determining what a match is. Same thing here for complies, especially because you already have the numbers already measured. So that said, I'm going to wrap up this video now. I wanted to just give you a chance to go through a couple different C of A's with me so that you can see some of the things that I see when I see documents online through products that are available in the marketplace that I don't trust. I don't like them. The documents aren't clean. The C of A's look borderline lab shopped or dry labbed. And especially when people are talking about things that don't actually exist, like terkesterones, for example. So hopefully in the future, as you are shopping for products, ideally at Nootropics Depot, but wherever you're looking and you're looking at certificate analysis, you can look at it with a more critical eye, and you could say, does this make sense? What would Jay think about this? And on that topic, if you have C of A's that you see, you can contact me directly through www.omnientlabs.com. Hit the contact us and the service us or whatever the button is, and it'll send me an email, and you could submit your C of A, and we'll take a look at it, or I will take a look at it, and I'll just do some of these things. I'll say, here's what I see. I'm not going to tell you what to do about it. I'm not going to make any claims about the company. They're obviously for legal reasons. There aren't going to be liability issues. I'm going to say, here are the scientific issues that I take offense to in this document. So hopefully that helps you guys out in the future, and if we get enough of those responses, maybe I'll make another video and I'll say, here's a bunch of C of A's people have sent me. Here are the things I picked out for them. So if that's a useful service to you, contact me on the internet. You can also find me on u/Omnient Labs on Reddit, and we can take it from there. So that said, hopefully it was helpful, and we'll see you guys in the next video.